I'm here with David Deutsch. David, it's great to see you again.
Nice to be here again.
It's been a long time. I didn't actually check to see when our last conversation was, but I think it's probably about 5 years ago. It has to be.
Wow, is it that long? Yeah,
yeah.
Well, a lot has happened since.
Yeah. It's history has been eventful. So I'm going to take us on a tour through many topics about which you are well qualified to have strong opinions. The first will seem intimately related as they relate to science, about which you have thought much. But at the end, I want to talk about world events and the explosion of anti-Semitism we've witnessed since October 7th, 2023. I know you're connected to those topics as well. So you and I've had at least two very long podcast conversations where we dealt with mostly the topics in your second book, The Beginning of Infinity, and then tried to bridge a conversation between that and the foundations of human knowledge, its prospects for the future, and also just how that relates to human values and morality. So people can go back and listen to those conversations. We have at least 4 hours, if not 5, on those topics. But here I realize we've neglected to talk, I think, at all about the topic covered in your first book, The Fabric of Reality, which was the many worlds interpretation of quantum mechanics, among other things, and also your more recent work, constructor theory, your contributions to quantum computing, and also just how you view the state of that. You and I have spoken about artificial intelligence before, and I'm going to want to just hear about your recent thoughts on that and your experience of the developments in the technology. And then again, we'll talk about the tractor beam of a very ugly history that it seems to be pulling us all back into the stream of things that would be best left behind us. So let's talk about quantum mechanics and your favorite interpretation of it, the many worlds thesis. What is that?
So first of all, I've long ago gone off calling it an interpretation. I think calling it an interpretation is part of the thing that went wrong with physics in the mid-20th century, where because people didn't like what quantum theory was saying about reality, they invented, well, I guess it was invented by philosophers, but physicists latched on to this idea that the scientific theory consists of a mathematical formalism which doesn't have a meaning, and then an interpretation which assigns a meaning to each of the mathematical objects. And so and by definition, then, neither of those by itself is testable.
Right.
So only the two together are testable. Now, I think that's
Actually, David, can I just pass over that ground one more time just to make sure people understand what you're saying? So you're saying that it was in fashion for many generations to view quantum mechanics as a calculation device that produced absurdly accurate answers, but the picture of reality that it was giving us was open to many quite discordant interpretations. I mean, they were completely irreconcilable. They looked like very different pictures of reality, and we were left with physicists picking their declining to do that at all and just go on calculating. And so it was just not clear what picture of reality quantum mechanics was giving us.
That's what the consensus view has been and probably still is. But I disagree with that. I think there's only ever been one interpretation of quantum theory.
That is the same thing that happened with art. Just because the statement beauty is in the eyes of the beholder holds some truth about the taste, does not mean that the whole concept of beauty is totally subjective. It's not. There are objective criteria related to what is beautiful. And the taste and the eye of the beholder does not mean that the whole concept of objective truth related to beauty is to be denied.
And it was invented in the 1950s by Schrödinger and then Everett, who developed it properly. And it says, among other things, that the reality described by quantum theory is one of many universes. Or by universe, I mean the thing we see around us, the thing we see with telescopes. It's an enormously vast thing. But quantum theory says that true reality consists of that and many copies of it and a lot more. So, and that we call that the multiverse.
Right.
And so these interpretations of it, for example, things like the nothing exists except what we observe, and therefore when the calculational tools say that there are many of us observing many instances of the thing, that doesn't say anything about reality. That's just a calculational tool. And what really happens is that when we finally observe something, all the various versions of us collapse, as it's called, and only one of them remains, which is much like the universe of classical physics, which my favorite analogy for this is well, first of all, note that nowhere else in science does anyone do this. It's only in quantum theory that one splits the predictive part of the theory and the explanatory part like that. So I like to say that this is exactly like if there was a controversy about whether dinosaurs existed, whether the creationist account of the origin of fossils or the biologist's account, and people said, well, they're just interpretations. I mean, the universe was formed 6,000 years ago, and whoever created it, the creator, put fossils into the ground to test our faith or whatever.
Right.
And so therefore the idea that there actually were dinosaurs, which no one has ever seen and no one will see, and there's no evidence that any times before 6,000 years ago existed, because all that evidence is just, according to our theory, artificial. And so when you, and by the way, we don't see dinosaurs. People say we see dinosaurs because we see their fossils, but fossils are actually stones. All the dinosaur has disappeared long ago, and fossils are just stones which take on the shape of the dinosaur in reality.
So you're saying that as scientists, it should matter to us which of these pictures of reality is in fact true, and only one of them can be true. And the fact that you can cook up a highly implausible but nonetheless unfalsifiable variant does not mean that we should consider it as an equally serious candidate for being true.
That's right. In fact, the dinosaur theory, the creationist dinosaur theory, is actually much more specific and detailed than the so-called other interpretations of quantum theory, because they always have a thing like, and then a miracle occurred, which is a bit like, and then God created it. But the thing is, they are willing to say what God created, whereas the other interpretations of quantum theory do not say that. They in fact, they say you're not allowed to ask what happens between the setting up of a quantum experiment and viewing the outcome.
Well, let's remind people of just the kind of the heart of this controversy, because I think people will have heard of specific things like the double slit experiment or the Schrodinger's cat, right? And one of these, I mean, maybe Schrodinger's cat is the best place to illustrate the variant here. Just what has been the standard view of the seeming paradoxes here, and what has been the temptation to follow Hugh Everett into the many worlds theory?
By now, I think the standard or prevailing theory is just the shut up and calculate, as you mentioned at the beginning, because people have got really tired and feel vulnerable using things like the collapse interpretation, which has got so many holes in it by now. So I think most physicists just say, well, you know, I'm not interested in that. I'm only interested in getting results.
And the collapse interpretation again. I just feel like we need to double click on some of these things so that people who are not haven't recently read one of your books or another book on physics will follow us. So it has long been thought that observation plays a key role in reality becoming what it is at the quantum level. So Schrodinger cooked up a thought experiment which I believe sought to illustrate how deeply counterintuitive and perhaps unacceptable the state of affairs was. The idea of the cat in the box, waiting to be killed or not based on the decay of some radioisotope, and it was then left to the greatest physicists of the time to imagine that their physics was telling them that the cat was neither alive nor dead. It was in some so-called superposition of those two states until one of the physicists opened the box and observed whether it was alive or dead. And this is true, so I mean, this begets many questions, but starting there, what is unacceptable to you about that, and then what does many worlds tell us is in fact true?
Right. Well, what's unacceptable to me and to Schrodinger was that this state, not that this state could exist, of half alive and half dead or whatever, a superposition of alive and dead, but that when you open it, this resolves into one of those two. So what is it that resolves it? Well, being observed. Some people said it's being conscious of some people said it's when the outcome becomes known to the scientific community. And meanwhile,
it gets peer reviewed. Yeah.
Yes, exactly. And originally, Niels Bohr, who kind of set off this silliness, said you're not allowed to ask. That quantum theory does not answer that question of what was happening in between when the state was prepared and when it's observed. You're not allowed to answer that. Physicists don't like that. So they produce these various interpretations that make even less sense than that, because by the way, Niels Bohr also said that it's no good looking for a theory of what happens in between those two times. Quantum theory is a complete theory, and therefore what it says can't be asked, really can't be asked. It's something one is not allowed to theorize about. So Einstein and some others couldn't accept that, because they thought that physics in particular was about how the world actually is, not about what we are allowed to say or think.
Right.
So so I've forgotten what the question was there.
So the question is, so if it's not consciousness that's collapsing the wave function and resolving this superposition, and one could wonder whether the consciousness of the cat, if it has consciousness, why that would be insufficient. How does many worlds come to the rescue? What is said to be true now?
Okay.
Yes. By the way, you have to say the consciousness of the cat does not affect it, because in principle we could reconstruct the interference. So long as the wave function hasn't collapsed, you can restore the initial state and have the cat and the poison not be affected yet. So it has to that does. Somebody who is somehow connected with the laws of physics. Now, what happens according to Everettian quantum theory is that when we do an experiment, countless numbers of us, or if you like, a thick layer of us, a stratum in the multiverse with many identical copies, all of them setting up the experiment and starting the apparatus going. All of those remain identical to each other until they look at the cat. And at that moment, the interaction of the outside world with the cat and with the version of us makes us differentiate into two copies, or actually millions of copies, but let's just say two copies.
Okay, but wait a minute. Where did these copies of us come from?
They were already there in the modern interpretation of in the modern version of the theory. The way that Everett originally framed it, or rather the way that DeWitt originally, Everett himself didn't have an opinion about this, but DeWitt called it splitting into two. Mm-hmm. But since then, the consensus among Everettian physicists is that the multiple copies are always there. Some of them perform this experiment, and from then on, we can talk about them, what happens to them. Mm. And then that continuum of observers or of experimenters differentiates that they're no longer identical. The interaction with the cat makes them no longer identical, just as the cat itself is no longer identical across the swathe of universes in which it exists. In half of them, it is alive, in half of them, it's dead. Mm-hmm. When we interact with that, the same thing happens to us. Mm. We see alive and we see dead in different universes.
But so the copies that were already present before the experiment was performed, these presumably were made in prior splittings based on prior quantum events, correct?
So there are parts of the multiverse in which we don't exist at all because the planet that hit the Earth billions of years ago destroyed all life.
Mm-hmm.
Okay, so this, I must admit, this, at first glance, and perhaps even a second glance, seems like the least parsimonious theory ever proffered. And we seem to be, at least we imagine we're in the parsimony business in science. How is it that this is acceptable? This idea that, I mean, can this be summarized by saying that everything that can happen does happen?
Well, everything that can happen according to the laws of physics.
Right, but literally, so everything that's possible, is it the same as saying that everything that's possible is in fact actual somewhere?
Everything that's possible according to the laws of physics is actual somewhere, but you have to add that most of those things, that those things happen in widely differing proportions of the multiverse. Mm-hmm. So if I toss a coin, roughly 50% of the worlds will see heads, roughly 50% tails, but a few of them will see the coin melt and dribble off the table onto the floor.
Mm-hmm.
Okay, so this is now kind of amounting to a bit of a sidebar conversation. I'll get us back to the main topic, but this interests me. So what this does to the notion of possibility is that it conserves it in the sense that while there's no such thing really as possibility, everything that can happen does happen. It doesn't happen the same number of times, so there's kind of like a frequency difference across the multiverse.
Mm-hmm. Yes, it turns out that frequency is not good enough to support the notion of probability that we need in physics and in everyday life. And I inaugurated a research program called the Decision Theoretic Approach to Probability in Quantum Theory. Others took that and ran with it, and now we have a really watertight version that's not based on frequency, but it's based on what a rational person would do if they thought that there are Everettian universes and that the future is going to differentiate. So it comes to the right answer. So there isn't any dramatic conclusion from this, except that probability works as it was postulated to work from the beginning of quantum theory.
But probability in this case is a useful fiction?
Yes.
Okay, so we're in a kind of actualist universe. There is only the actual.
Yes.
And it just happens a countable number of times. And those number of times are different depending on what we're talking about.
Yes, a measurable number of times,
Right.
but a countable number of different times, yes.
Right. Okay, well that's, the nerds can thank us for that little detour. Again, back to this question of parsimony. This just does seem on its face to be multiplying things quite literally way too much to seem plausible. How, okay, before we dig into more of the details, what was your psychological, okay, give me your biography with respect to this theory. How long did you accept it? What was that process like? And what do you recommend to those who are hitting stumbling blocks on it?
Well, I was a graduate student at the time, a first year graduate student, and I'd heard of this theory before, and I thought it was, like you said, I thought it was one of a number of different interpretations that one could use for the formalism, and I was just learning the theory, and I was obsessed with physics at the time, not metaphysics. So I didn't much think about it until, well, two things happened. One is that I met Bryce DeWitt in a pizza place in Oxford, and we were having lunch, and a bunch of us, and I happened to know that DeWitt had been active and in promoting Everett's theory. So I asked him, I forgot what I asked him. It was very kind of him to answer because he'd probably been asked this question hundreds of times. But I asked him something like, well, if there are many copies of me, which one am I? And he very gently said, well, you are actually all of them. And they are all asking that question. And he explained it to me. We went into the details of the theory as well. I was going to say mathematical details, but it was the physical details that we went into. And by the end of that conversation, I was convinced. But I was still not very interested.
Well, some of you were convinced. There have to be parts of the multiverse where you were not convinced, and you walked away astounded that a fellow Oxfordian could believe such a thing.
You're omitting the existence of error correction, and error correction is a very important part. It's a very fundamental part of human thinking, especially rational thinking. So you might think that there's a 50-50 chance that I would get up from that table convinced and not convinced.
Well, not 50-50, but maybe even just 1 in a million, right?
Good point.
There's some universe where you died, you were struck dead mid-sentence by the power of his words, right?
That has got nothing to do with being persuaded and not persuaded.
Yes,
let's consider
true.
the universes in which I survived.
Okay.
Then I think the ones in which I was not convinced are a tiny proportion. It's like if someone wanted to say to me that electrons are actually as massive as bowling balls, and there it's the other way around. He wouldn't, in most universes, he wouldn't have persuaded me. It would take something like a cosmic ray strike to undo the error correction that would have happened.
Well, so then what do you make of the failures of error correction, at least on your account, demonstrated by your fellow physicists who don't accept this theory? I mean, presumably there were people, even contemporaries of DeWitt and Everett at the time,